Cosmology is a branch of astrophysics and astronomy. It studies the universe as large scales. So we have our solar system. The solar system is around the sun. The sun is only one typical star. In our galaxy, the Milky Way, there are 100 billion stars. And our galaxy is a typical galaxy. And in the observable universe, there are about 100 billion galaxies. So cosmology studies this as a model, as a whole model. It is based, it uses physics, it uses mathematics, computations, observations, data, and it also, it's based on a model. The model is called the Friedman-Lemaitre-Robertson-Walker model of cosmology, standard model. This is four scientists that worked on introducing this model. It is also based on the theory of general relativity of Einstein. What is general relativity? General relativity is the theory of gravity that was introduced by Einstein. It came as an improvement to the theory of Newton of gravity. So which one is more precise? So here is an interesting thing. So Newton theory works with forces, but general relativity talks about the space-time, and there is curvature of space-time. So objects are falling and moving in the curvature of space-time. It looks like an interesting idea, like, is that real? The answer is surprisingly yes, because if we look at general relativity and we compare it with Newtonian gravity, general relativity is more precise. How? First, general relativity explains some motion of the planet that Newtonian theory does not explain. That is called the precession of Mercury. Such a surprise, such an important thing. There is also the bending of light. The bending of light has a factor of 2 compared to Newtonian gravity, and was also measured to be not of Newton but that of Einstein. And finally, our GPS, if you don't put in GPS a correction due to relativity, it will be off by 38 microseconds every day, which means you will be off by 10 kilometers every day. You go to your house, and if you follow your GPS or go somewhere, it's 10 kilometers away. So I call that the triumph of general relativity. So the theory is solid. It's proved to be better than that of Newton. Now, how about cosmology? What is the triumph of cosmology? It predicted the existence, the presence of what is called the CMB, the cosmic microwave background radiation. That is photons that are all around us. And where do they come from? They come from 13.8 billion years from the time just after the Big Bang. It was predicted by Gamow, and it was measured like many years afterwards. In fact, if I take a centimeter cube here, inside that centimeter cube, there is 400 photons that pass, or they are contained actually in this 1 centimeter cube. I call this a triumph of cosmology, of general relativity. We do have now an understanding that the age of our universe is 13.8 billion years, and that all comes from cosmology and general relativity. So I call this really a triumph of science. But this did not come without surprises. So there is the mystery of cosmic acceleration. We know that the universe expands, but we don't know why the universe accelerates in this expansion. This is a big mystery. It could be due to some dark energy component in the universe. It could be to a modification of general relativity. It could be for some reason. We have no idea what it is, but once we understand it, it will change our understanding of space and time. We have great mysteries. We have great data coming. And then we have great ideas. I believe that this is a great conjecture, and we are up to great discoveries. So wonderful time to be a cosmologist. Stay tuned.